Welcome to part 2 of stoichiometry practice. Now in this particular video, we're going to be learning how to do mole to mass conversion. And I'm going to just write that over here so that we have a frame of reference of what we're doing. So what mole to mass or mass to mole. In the last video, you did mole to mole conversions, as well as we reviewed how to do mole ratios. So we're going to start off with the equation, which is a simple synthesis equation of copper plus oxygen gas gives us copper oxide. It's actually copper 2 oxide. So we look at this equation, you'll notice that it's not balanced. So of course, that's the first thing you always have to do when you're doing any of these type of conversions, is they have to be balanced. So in our reactants on the left, we have 2 oxygens, whereas we only have 1 oxygen in our product. So, and we have 1 copper on the left and 1 copper on the right. So we could easily just go ahead and put a 2 here. That'll give us 2 oxygens, but it also gives us 2 coppers. So then we need to go in and put a 2 there. So now we can look and notice that we have 2 coppers on the left, 2 on the right, 2 oxygens on the left, 2 on the right. As I said in the previous tutorial, I told you that you don't always have to write out all of your mole ratios when you're doing these problems, especially if you know that you can easily eyeball it with the coefficients and know exactly what the ratios are. And especially in a problem like this, where this is pretty simple. You have 2 coppers for every 1 oxygen. You have 2 coppers for every 2 copper oxides. You have 1 oxygen for every 2 copper oxides. And then, of course, you can always just reverse it. So we're going to start off with working some problems with going from mole to mass or mass to mole. In these type of problems, it's always going to be very important to pay attention to what's given and what is being asked of you. And once again, you want to make sure you have some paper and a pencil with you so that you can work along these problems with me. Okay, so let's start off with the first problem. I'm just going to put number 1 here. If 101 grams of copper is used, how many moles copper 2 oxides, that's Cu2O, will be formed? Let's look at the problem of what it wants to know. It says if 101 grams of copper, so if that much copper is used, how much of the CuO will we form? That's the question it's asking. So what you're able to do first is you want to know how many moles of copper is that 100 grams. What's the first thing you want to know? So the way you have to do that is you need to convert that copper to moles. So we're going to do step 1. Convert the grams to moles. So the way we're going to do that is, first of all, you can still start off and say, I was given 101 grams. Let's see, I'm just going to click. That's what I was given. I need to know how many moles that is. Guess what you always do know? You always know how much 1 mole of a substance is, especially an element, because you get that from the periodic table. So you can multiply the fraction of mole to grams, or you're essentially dividing. But I say fraction because I'm going to show you how I'm setting it up. And hopefully you remember this actually from problems that we did when we were doing mole calculations in the first half of the course before we got out for Christmas. So we know that for every 1 mole of copper, it is actually equal to its atomic mass, which is 63.55 grams. And I got that from the periodic table. essentially, what we are doing to go from grams given to moles is we're dividing the given grams by the actual weight of the element or the substance. That's all I did. So I'm going to divide that 101 by 63.55. So of course you always want to have a calculator so that you're able to do that. So then that tells us that 101 grams of copper is equal to 1.59 moles of copper. Because here, our grams copper and grams copper cancel out. We divide 101 by 63.5, multiply times 1, of course, then that's just 1. So 1.59 moles of copper. So let's now insert that into our question. Now our question says, if 1.59 moles of copper is used, how many moles of copper oxide will be formed? So this is when it becomes a mole to mole. So step 2, we're going from moles to moles. So we're going to insert our given, 1.59 moles of copper. We're going to multiply that times our ratio of copper oxide to copper, because we're trying to find out the copper. So whatever you're trying to find out or solve for, it always goes at the top of our ratio. So if we look here, we see that in a given basic equation, we always have 2 moles of copper oxide for every 2 moles that's over here. It's, probably can't see it because this is in the way, but that was a 2. Let's see if we can move that over, kind of help us out a little bit. There we go. So we have, our ratio is going to be a 2 moles of copper. And I got that from our mole ratio. In our mole ratios, for every 2 moles of copper, we always end up with 2 moles of copper oxide, we always end up with 2 moles of copper. So we didn't solve it. Now, this is kind of easy because 2 divided by 2 is 1. So this basically cancels out as far as our numbers. So it's essentially 1.59 times 1. So, and then we can cross out our moles copper and moles copper. So then our answer is 1.59 moles of copper oxide will be produced. So going back over what we did, the problem started off saying if we have 101 grams of copper, how many moles of copper 2 oxide will be formed? You first needed to know how many moles of copper are in that 101 grams. It's the first thing you need to know. The way we find that out is we have to convert 101 grams to moles. We do that by essentially dividing by the atomic mass, but we set it up as an equation because we are multiplying the fraction of 1 mole per the weight of copper. So that was 101 times 1 divided by 63.55. But if you want to get rid of that 1, you're essentially just dividing the given grams by the weight of the substance. So that's how we arrived at that 1.59 moles of copper. Then we now know that our question essentially reading, if we have 1.59 moles of copper, how many moles of copper oxide will be formed? So we're given 1.59 moles of copper. We multiply that times the mole ratio of copper oxide to copper, which was 2 to 2. And we end up with 1.5. Moving forward, let's look at another problem. So problem 2 says, if there are 5.25 moles of copper used, how many moles of oxygen will also be used? Notice here that I'm giving you a simple mole to mole. So here now we're not going to mole to grams, and the reason I'm doing this one is I want you to be able to pay attention to if we're doing moles to mass or moles to moles. So here is a simple moles to moles as a review from the previous video. So we're given 5.25 moles of copper. And we want to know how much oxygen will also be used. So if we look at our problem here, we need to know the ratio. So 1 mole of oxygen is always used for every 2 moles of copper. And once again, I got that from our equation. So we're going to just multiply out and divide. So then we'll take our 5.25 times 1, which of course is still just 5.25, and divide it by 2. That's going to equal to 2.63 moles of O2. So if we use up 5.25 moles of copper, we're using 2.63 moles of O2. Now let's bring back in going from grams to moles. So we have 78.2 grams of oxygen. To react with copper. How many moles of copper to oxide? Apparently, I cannot type. Will be produced. Let's look at our question. We're given grams of oxygen. We want to know how many moles of copper will be produced when this many grams of oxygen reacts with copper. Once again, let's go. We're going to start with our step 1. We need to know how many moles of oxygen is in 78.2 grams of oxygen. Now, keep in mind one very, very important thing, and I'm going to write it just to kind of remind you. We're using O2, not just oxygen. We're using O2. So because we are using O2, then we have to remember how to calculate that. So that's going to actually give us, we need to know that 1 oxygen is 15.99. Actually, 999. But we have 2 of them, so we're going to have to multiply that times 2 to get the mass of 1 mole of oxygen. So 1 mole of just oxygen is 15.99, but we have O2, so I did 15.999 times 2. So that's going to give us a value of 31.998. So this is how much is equal to 1 mole of O2. That's always the first thing, is you have to know how much is in 1 mole of your given substance. In our previous example with copper, all we had to do was get this from the periodic table. 1 mole was the atomic mass. However, here, because this is an O2, we have to know the molar mass, which is the weight of oxygen times 2. So now we can proceed. We were given 78.2 grams of O2. When we set that up, that's going to be times 1 mole of O2 divided by our mass of 1 mole of O2. So then you would take your calculator and you do 78.2 divided by 31.998. That's going to give you a value of 2.44 moles now of O2. What this tells us is that there are 2.44 moles of O2 in 78.2 grams of O2. So then that takes us to our next step, where we find out, well, if we have 2.44 moles of O2, how many moles of copper 2 oxide will be produced? So we are given now 2.44 moles of O2, because that's what we got from step 1. And we're going to multiply that times our ratio of copper oxide to oxygen. So our ratio is for every 2 copper oxides we get, it came from 1, and I'm going to put moles in there, apologize. For every 2 moles of copper oxide we have, it came from 1 mole of O2. So if we work this problem out, it becomes 2.44 times 2 divided by 1. So our answer would be 4.88 moles of copper oxide will be produced. So to review, we were given the grams of oxygen. And we wanted to know if we have this many grams of oxygen. Suppose you're in the lab and I told you to weigh out 78.2 grams of oxygen. But I wanted to know how many moles of oxygen are you using? You can't weigh that, but you convert it. So what you found out is that in 78.2 grams of oxygen, that is equivalent to 2.44 moles of oxygen. And if you start out with 2.44 moles of oxygen, you're going to produce 4.88 moles of copper oxide because the relationship of copper oxide production to the O2 reactant is that for every 2 moles of copper oxide, you used up 1 mole. So it's basically double. So hopefully that makes sense so far. And now we're going to do one more example in our mole to mass calculations. And I'm going to erase this. Right, and let's go back and add text here. So here's our equation. We're going to do C4H10 plus O2. This may be a familiar equation because I can remember giving this to you on an exam or quiz when you took balancing equation quizzes, and this one stumped some of you, but hopefully now it's not. So the first thing you always want to do, balance your equations, and I'm going to put that in bold. Balance equation first, so you can always remember you have to do that first. Let's look at what we have here. We have 4 carbons on the left and 1 on the right, 10 hydrogens on the left, 2 on the right. We have 2 oxygens on the left and 3 on the right. We're just going to pick a place to start. I'm going to start over here. Let's say we're going to put a 2 here. That gives us 8 carbons on the left and 20 hydrogens. And mind you, I just randomly started somewhere to figure out where I want to go from there. So that gives us, as I said, 8 carbons on the left and 20 on the right. 8 carbons on the left and 1 on the right. 10 hydrogens on the left. 20 hydrogens on the left and 2 on the right. So we know we have 8 here, so we're going to need an 8 here. Now we have 16 plus 1, so we have 17 oxygens on the right and 2 on the left. So we're going to leave those alone right now. I said previously we have 20 hydrogens on the left, so we're going to need 20 over here. So we're going to put 10 here. So now we have 20 hydrogens, and we have a total of 26 oxygens because we have 16 here and 10 here. 16 plus 10 is 26. So we have only 2 on the right, but 26 divided by 2 is 13. So there we have it. This is a balanced equation. Now, I kind of cheated a little bit because I already knew what the answer should be. But for you, you would have to maybe work it out a little bit. All right, so first thing is we want to figure out now how to go from, once again, going from grams to moles or moles to grams. Let's do our problem. Now, also, you would do your mole ratio or you eyeball it. We're going to eyeball it in this case. So we want to know how many grams of carbon dioxide will be produced If 3.5 moles of O2 react. So notice now we're going from grams, we're going from moles to grams. That's going to be a little different. Beforehand, we were going from grams to moles. So you'll notice that our problem is going to be set up just a little bit differently this time. So first step is we have to know how many, we want to know how many moles will we get of carbon dioxide from this many moles of oxygen. So this is what you're going to see a little different. So that's why it's very important to know what you're going from and to. So I'm just going to write that out so you'll know. This time we're going from moles to gram. Last time we were going from grams to moles. So the first thing is we have to know, one, we need to know how many moles will be produced. That's the first step. I need to know, I can't just jump from moles of oxygen to carbon dioxide moles. I need to know, well, how many moles will I even have of carbon dioxide first? So we're going to start with our given. We were given 3.5 moles of O2. We're going to multiply that times the ratio of carbon dioxide to oxygen from our equation. For every 8 CO2s we started off with 13 moles of O2 in our reactants. And then we're going to solve for moles of carbon dioxide. We're going to cancel out moles of oxygen and moles of oxygen here. So the way we'll solve this is we're going to go and calculate 3.5 times 8, which gives us 28, and then divide that by 13. The answer would be 2.15 moles of carbon dioxide. That's the first thing you have to find out. If we're starting with moles and we want to know how many grams will we get, we have to first know how many moles we'll get. If you don't know how many moles you'll get, you can't do the problem. So now step 2, you have to convert those moles to grams. When you're going from moles to grams, you multiply. All right. And I'm putting multiplied by the grams. The grams are going to be on top here. That's what we're solving for. So once again, we know that we have 2.15 moles of CO2. That's what we had here from the previous step. Now, we have to figure out, well, how many grams is equal to 2.15 moles of CO2? What do you know already? You know that in every 1 mole of CO2, it's a certain weight. Now, the way we can figure that out is you're going to take your carbon. To figure out 1 mole weight of CO2, I'm going to put that all the way over here so that you can have a little working knowledge of how I get this. So, carbon's weight is 12. Previously, we know that oxygen is O2, or CO2 here, that was weighing 31.998. Forgive me for all the typos. I'm kind of typing fast, faster than I'm talking. So we're going to add these together. So that's 12 plus 31.998. So together, CO2 is equal to 43.998. That's how much 1 mole of CO2 is equal to. We're going to multiply that over here. So then we know that 43.998 grams of CO2 is the equivalent of 1 mole of CO2. And the way to always remember what goes on top and what goes on the bottom, you have to kind of remember, what do you want your answer or your product to be expressed as? We want it to be in grams. So grams has to be on top because we have to divide out our moles. These are going to cancel out. And then your final answer will be expressed in grams. So that's going to be 43.998 times 2.15, which will then give you 94.6. So you'll have 94.6 grams of CO2 will be produced if 3.5 moles of oxygen react. Hope that makes sense. But guess what? We're gonna do another one. Give you a different reaction so that you can see it in other types of reactions, and hopefully it'll make sense for you. So I'm gonna erase this one with my eraser. So let's just get a little better at that. All right, so let's do a different reaction. Mg plus HCl gives us MgCl2 plus H2. Now, I hope you notice that this one is a single replacement reaction, because we start off with magnesium plus hydrochloric acid, and the magnesium displaced the hydrogen, so now we ended up in our product as MgCl2 and hydrogen gas alone. Notice that the hydrogen is diatomic, so it has to have two. So let's balance our equation. We have one magnesium on the left, one on the right, one hydrogen, two on the right, two CLs, one CL on the left, two on the right. It's just, since we know we have two CLs and two hydrogens on the right, but only one of each on the left, and they're written together, kind of simple to know that we just put a 2 there, and our equation is completely balanced now. So that was a simple one. So let's work some problems with that. So our question says, what mass of HCl is consumed? So how much of that reactant is used up by the reaction of 2.5 moles of magnesium? So basically, how many grams is actually asking? How many grams of HCl is going to be used when you react with 2.5 moles of magnesium? First things first, you have to know how many moles of HCl will be consumed when you have this many moles of magnesium. That's the first thing you have to do. So we're going to start off with step 1. We're going to do 2.5 moles of Mg. We're going to figure out how many moles of HCl we will produce. So HCl is what we're trying to solve for. So that would be the top of the mole ratio. And from our equation, we see that we always produce we have 2 moles of HCl in our reactant for every 1 mole of Mg. So that means we do a simple 2.5 times 2 divided by 1. So 2.5 times 2 is 5. Divided by 1 is still 5. So 5 moles of HCl. So what that's telling us is that when we have 2.5 moles of magnesium in this reaction, we're going to consume 5 moles of HCl. That's the first part. Now we know we need to convert this answer to grams. So since we're converting this answer to grams, we're going to start off with our answer here at 5 moles of HCl. When converting that answer to grams, then that means that grams are going to be on the top. We're going to multiply by grams. The weight of HCl is, the weight of 1 mole of HCl is 36.46. And if you want to make sure of that, you can always check the periodic table. for your atomic masses so that you could double check those numbers. You would find out that the atomic mass of chlorine is 35, and then the atomic mass was actually 35.453, and then the atomic mass of hydrogen is actually 1.007. So you add those together, you get 36.46. You round everything up. So 36.46 grams HCl is the amount in 1 mole of HCl. Our moles of HCl cancel out, so we're essentially just doing 5 times 36.46, which will give us 182.3 grams of HCl. I want to make sure you see where we're getting this from. So, first thing is we were told 2.5 moles of HCl. And we wanted to know how many grams of HCl would be consumed in that reaction. But since we can't just jump and just do it in a one step, we had to first know, well, how many moles of HCl is produced when we have 2.5 moles of magnesium. So then we use our normal calculation of mole to mole where we multiply times our ratio to get 5. Now we know that every time we have 2.5 moles of magnesium, we have 5 moles of HCl. So then we have to know, well, how many grams is that? We know that there is 36.46 grams of HCl in 1 mole, but how many is it in 5? So you multiply this times 5, and we find out now that the answer to our problem is 182.3 grams of HCl is consumed by the reaction of 2.5 moles of magnesium. Now I'm going to do one more using the same reaction. So what mass of MgCl2 is produced if 3.67 moles of HCl react? First things first, since in our problem, we're going from moles over to grams. So the first thing that we have to know is that we have to understand that we're going from moles to grams. But we also then first must know how many moles of MgCl2 will we get from this amount of moles of HCl. So let's write our given 3.67 moles of HCl and multiply it times the ratio of MgCl2 to HCl. So for every 1 MgCl2 that is produced, it came from 2 HCl's. We're going to type moles in there. Okay, so let's solve the equation. So 3.67 times 1 is still 3.67. We're going to divide that by 2. So that gives us 1.84 moles of MgCl2. So what that tells us is for every 3.67 moles of HCl, we produce 1.84 moles of MgCl2. But we want to know the weight of this. What's the mass that we will have? So if we were doing this reaction in the lab and we wanted to weigh to see if everything was completely reacted and how much did we produce, we would be weighing in grams. We would want to know the mass of this. So in order to know the mass of it, we have to convert our moles to mass. So we have 1.84 moles of MgCl2. And we want to know how much does that weigh? That's basically what we want to know, is how much does 1.84 moles of MgCl2 weigh? We do know or we can find out how much 1 mole of MgCl2 weighs. We know that chlorine is 35.453, and magnesium is actually 24.305. So I'm going to put that over here. Just add it over here somewhere. Well, no, that's not what I want. Okay, let's figure out how to reverse that, shall we? Well, that went awry, didn't it? Let me just retype it really quickly. I don't really know what happened. Or what mass of MgCl2, sorry y'all, produced is 3.7 moles. I apologize for the technical difficulties here. When we figured it out, we had 3.7 moles HCl times our ratio, which was 1 mgCl2 divided by 2 moles of HCl, which equals to 1.84 moles of HCl. Alright, so that's what we were. Now we're gonna do 1.84 moles, and we're trying to determine how much is in 1 mole. So magnesium is equal to 24.305. Chlorine, we know, is equal to 35.453. Now we have to multiply that times 2, because our formula says MgCl2. So we're going to multiply that 35.453 times 2. Which gives us 70.91. A little extra, 70.91. So then we add that to our 24.305, and our answer is 95.21. So 1 mole of MgCl2 is equal to 95.21 grams. MgCl2 is equal to 1 mole of that. I'm going to add that back there. This was... All right, so we're going to solve for this. And what this is saying is we want to find out how many grams is 1.84 moles of MgCl2. So we're going to multiply 1.84 times the amount of grams in 1 mole, which is 95.21, and our answer is 175.19 grams of MgCl2. That is our answer. So now if we go back to our original problem and say what mass of MgCl2 is produced if 3.67 moles of HCl react. So then that question is basically saying, if we have 3.67 moles of HCl is in our reactant, we're going to produce 175.19 grams of MgCl2. That's what the question is saying to us. Now I'm going to do one more problem, and then I'm going to end this tutorial. So for all of these, I've gone from moles to grams. But what I want to do is do one where we flip it back and we go from grams to moles, because I want to make sure you understand the difference between the two. And clearly I keep doing that. I don't really know what I'm doing on that one, but let's see if we can make this work. There we go. All right. So here is our reaction that I'm going to put up. show you NH3, which is ammonia, plus O2, going to yield N2 plus H2. Let's balance it really quickly. I'm going to do the balancing really quickly. So we have 1 nitrogen on the left, 2 on the right, 3 hydrogens on the left, 2 on the right, 2 oxygens on the left, 1 on the right. So we have 2 on the left. Let's go ahead and put a 2 over here. That's going to give us 6 hydrogens. So let's put a 3 here so we can get 6. But if we do that, it doesn't really work for us because now we have 3 oxygens, but we have these 2 over here. So that's not going to work out very much. So we need to double everything that we've done. So let's double our nitrogens. So if we put 2 here, change that to a 4. Now we have 12 here. So we need a 6 to make that 12 hydrogens. And then we can change this and make it a 3. Now we're balanced. I know I went through that pretty fast, but feel free to pause and look at it slowly so that it makes sense for you. All right, so I'm going to do 2 problems. The first one, I'm going to show you what happens when we're given grams and we want to know the moles. Then I'll do one more with this same reaction where we're given the moles and we want to know the grams. So I want to show you the difference between the 2 on the same screen. So here we go. I seriously do that? No, didn't want to do that. All right. So let me just retype that. As I said, I really hope that you're following along with me by writing this on your own paper because that's how it's going to make a little bit more sense to you. All right, so here's the first problem. I'm going to write it out for you. How many moles of nitrogen gas will be produced if 12.6 grams of ammonia? Yeah. So, you know what are you given? You're given grams. You want to know moles. We're going from grams to moles now. So, grams to moles. And you're going from grams to moles. I'm going to give you a hint. You're going to basically end up dividing by the grams because we want to get rid of the gram. All right, so if we want to know how many grams of ammonia will produce a certain amount of moles of nitrogen, first thing we need to know is how many moles of nitrogen will we get from that many moles of ammonia? We have to know that first. Then we can figure out how many moles that will be. So we're going to start with our given. Always start with the value you're given. So 12.6 grams of ammonia. That's what you're given. And we're trying to figure out how many moles that is. Because you cannot just jump over here from grams over to moles. So we need to know if we're given 12.6 grams of ammonia, how many moles is that? How many? I don't know. Let's find out. So we always know how much is in 1 mole of something by using our simple math and our periodic table. So if I told you, well, go and look at your periodic table and tell me what is the mass of nitrogen. And you would tell me that it is 14.0067. So nitrogen is equal to 14.0067. And I said, well, what's the mass of hydrogen? Because you got to know that too. But guess what? We have 3 hydrogens. So we're going to have to multiply the mass of hydrogen by 3. So 0.0784 times 3. We're going to add all of that together to get the mass of NH3. I'll give you a second to do the calculations on your own because I just want to see if you can get it. So you would do 1.00784 times 3. And then you're going to add that to your 14.0067. and you end up with 17.03 grams of NH3. So that's how much is equal to 1 mole NH3. Let's go back and put that in our problem. So 1 mole is equal to 17.03 grams of NH3. Now, I can remember when we went over this in class several months ago, one of the biggest things is you guys were struggling always with what do I put on top and what do I put on bottom. The way you always remember that is always remember, what do I want my answer to be expressed in? In order to get this, we are trying to go from grams to moles. So my answer has to be expressed in moles. So if that's the case, I'm going to divide away my grams so that all I have left is moles. So we're going to take our 12.6 grams of ammonia given, and we're going to divide that by 17.03 grams of ammonia because that's how much is in 1 mole. So when we do 12.6 divided by 17.03, your answer is now 0.74 moles of ammonia. So what does that say to us? That says that 12.6 grams of ammonia is equal to 0.74 moles of ammonia. But the question now wants to know, if we have 0.74 moles of ammonia in this amount, how many moles of nitrogen gas will we produce? So now our given is 0.74 moles of ammonia. And we're going to multiply that by the mole ratio of nitrogen gas to ammonia. So we see that the ratio is 2 moles of N2 for every 4 moles of NH4. So we're going to do 0.74 times 2 divided by 4. And our answer is 0.37 moles of NH3. Hopefully that made sense. But on the same screen, I am going to show you what happens if we go from moles to grams. Same screen. I want to make sure you're looking at the differences. So how many grams of water will be produced if 0.55 moles of oxygen react? Let me say it's all right for type. Right, so now let's look at what we're given. We're given moles. We want to figure out grams. We notice something different here, grams to moles. Now we want to figure out moles to grams. So guess what? It's going to give you a little hint. Really, you will end up multiplying by grams. Just hopefully that hint helps you. So first thing first. Start with what you were given. You were given 0.55 moles of O2. If we want to know how many moles of how many grams of water will be produced from this many moles of oxygen, the first thing we have to know is how many grams of oxygen do we have? We have to know that. If I want to know how many grams of water I'm going to get, well, I have to know how many grams of oxygen that I have in the first place. I know how many moles I have, but how many grams do I have? So we got to convert this over to the amount of grams. So the way that we're going to do this is first we have to know how many moles, I'm sorry, and I said that completely wrong. I'm just going to rewind and fix that. So if we want to know how many grams of water this many moles of oxygen is going to produce, and I completely misspoke, I'm sorry. You have to first know how many moles of water this many moles of oxygen will give you. Clearly, I've been talking a long time on the video at this point. So the first thing we have to do then is find out how many moles of water do we get from this many moles of oxygen. Simple thing, multiply times the ratio. If we have, so for every 6 moles of water, we have 3 moles of oxygen. That's the first thing. If I'm starting with the moles, I have to know how many moles of this I will have before I know how much it weighs. So I'm going to multiply times the ratio. So that's going to be 0.55 times 6 divided by 3. I'm going to give you a chance to work that out. So 0.55 times 6 divided by 3. That says that 1.1 moles of H2O. So what did I just find out? I just found out that if I have 0.55 moles of oxygen, I will produce 1.1 moles of water. Now the next thing is, how much does it weigh? That's what we want to know. I got how much I know how many moles I just produced, but I don't know how many grams that is. So now that's when we come in and say, give my given. I have 1.1 moles of H2O. I have no clue how much it weighs. So this is when I'm going to say, well, I need to multiply by the grams because I need my grams to be on top because I need to divide this away. I don't need this. I need the grams. So guess what? We're going to look at how much does H2O weigh. How much does 1 mole of H2O weigh? So you take your hydrogen, which is 1.0067, which we saw higher up here, 1.00784. Multiply that times 2 because H2O has 2 hydrogens. Then we're going to add that to the weight of 1 oxygen, which is 15.998. So 1 mole of water weighs 18.01 grams. Once again, I'm putting this in the numerator because I want my answer to be in grams. This is how much is in 1 mole of H2O. I'm going to divide these units out. I'm going to multiply this 18.01 times 1.01, and my answer is going to be 18.19 grams of H2O. So what that answer now gave me is it tells me that I will have 18.19 grams of H2O produced if 0.55 moles of oxygen react. So let's compare the two things that we saw. Here, we were given grams, and we wanted to know how many moles we would have. Before we could do that, we needed to convert these grams to moles. So we took this, the amount of grams of ammonia, and we found out how many moles that was. Then we simply multiplied that many moles by the mole ratio that we get from looking at the coefficients. Here, we wanted to know how many grams do we get from this many moles. So here we were given moles, but we needed to know eventually how much would that weigh in our product. So because we were given the moles, we start off with multiplying times the mole ratio to find out how many moles will we produce. Then we convert it to grams. So hopefully, even with my missteps a little bit, I'm sorry about that. Hopefully this makes sense. I know it's a long tutorial, but I wanted to be very thorough to help you know how to do these calculations. So this is part 2 ending. In part 3, I will go over how you go from mass to mass.